With this short talk, I'd like to introduce an open issue we are experiencing in the Italian National Institute for Nuclear Physics, and especially I'd like to propose you our solution. If you consider a time window quite large, as 1 year long, for example, you can observe the trend of the computing activities performed by user team in the public research is not constant in time. As a result, even the resources required for the execution follow such trend. And it often happens that number of user requests for consuming resources widely overcomes the resource availability itself. Therefore, since the research data center provides just limited capabilities, it becomes necessary to maximize their utilization by adopting a proper resource allocation model. And basically, there are two models, the dynamic partitioning model and the static one. And typically, the public research prefers just the first model because it enables the provision of an average computing capacity guaranteed for long period with respect to the static model, which is just based on an agreed and fixed amount of resources available at any given time. The current OpenStack version allows just a static model by assigning agreed and fixed quota to every project. So it follows that one project can exceed its own quota even if there are several user resources but just assigned to different projects. Therefore, in a scenario of full resource usage for a specific project, new requests are simply rejected and forgotten. Moreover, past experience demonstrated that whenever resources are statically partitioned in the research data center, the global efficiency in terms of resource handling is usually quite low and often is less than 50%. So we have to make OpenStack to be more efficient and flexible in terms of resource handling. For sure, this is not a new problem. Actually, it has been already solved in the past by advanced scheduler which implement complex FairShare algorithms which enable a continuous full utilization of all available resources. In particular, such algorithms guarantee the resource usage is equally distributed among user and groups by considering the amount of resources assigned to each of them and their historical usage. As you know, the OpenStack architecture has a component with scheduling capabilities named Nova Scheduler. Actually, it is not a real scheduler, but just a resource supplier which processes the user requests sequentially, one by one, and rejects them if no resources are available at a time. What's really missing in Nova Scheduler is a queuing mechanism for handling user requests, and especially a FairShare algorithm in the resource provisioning which led to maximize the full resource usage and guarantee at the same time the agreed quotas. We started to address this problem by developing a new pluggable scheduler named FairShareScheduler, extension of the Nova filter scheduler. As you can see from the schema, the FairShareScheduler is a fully integrated OpenStack architecture and extend the filter scheduler capabilities by providing a mechanism which assigns dynamically the proper priority value to every user request, calculated by an advanced FairShare algorithm, and then stored in a persistent priority queue. To do it, we analyzed the most relevant FairShare strategies, and we selected the SLURM priority multifactor, which is, in our opinion, a complete and quite documented FairShare algorithm. This picture shows the high-level architecture for our prototype. To every user request coming from dashboard or command line is assigned a proper priority value calculated by the FairShare manager. And then they are inserted in a persistent priority queue by a priority queue manager. And whenever some resources are released and become again available, a pull worker thread fetch from the queue the requests having a higher priority and process them in an asynchronous way by applying the same filtering and waiting phases as the filter scheduler does. Finally, for what concerns the failed requests, they may be inserted again in the queue for hand time for allowing an automatic retraining mechanism. The FairShareScheduler doesn't require any changes in the OpenStack architecture, and to prevent any possible interaction issue with the OpenStack client, we haven't introduced new state. So that from the client point of view, the query requests remain the scheduled state until they're processed. Finally, the priority of the query request is periodically recalculated to give the possibility to the holder request to scaling up in the queue. The FairShareScheduler is ready for the both Havana and iSauce version, and you can find the source code in our GitHub repository. Moreover, testing are in progress in the Italian cloud testbed, as well as at the University of Victoria. Of course, we wish to integrate our work in the official OpenStack distribution, and to do it, we started interaction with the Blazor team. To conclude this talk, I'd like to recall you that the computing activities in the public research require an optimized resource allocation model to be fully efficient in the OpenStack-based cloud environment. And we propose you our solution named FairShareScheduler, which aims to address and solve this optimization issue. Thank you.